Alright, I'm working on a theory to deal with the propagation of light. There's a few inconsistencies that really bother me, especially when you're dealing with the energy of light, the emission of light, and if it really does come from the electrons or if it actually comes from the protons in the nucleus. The reason why I say it might come from the protons in the nucleus is because if you take salt and put it in a Bunsen burner or an element and you run electricity through it, it should open up all the active shells. So each group in the D shell or the E shell should emit uh, all the light from all the shells, but they don't. They only emit certain light wavelengths, and it's always consistent with the number of protons in the nucleus, but not consistent with the number of electrons that are traveling through the shells. So that's proof to me that it's not actually coming from the shells themselves. So anyway, something else to keep in mind is that the rotational frequency of all electrons is constant. So since the rotational frequency of all the electrons is constant, then that means the nucleus must be spinning and the electrons aren't. I say that because as the speed or the electron goes further out in the shell, it speeds up, and as it speeds up, its rotational frequency is the same. But anyway, I've been working on, I got notes and pages, but anyway, let me try and find it really quick. Alrighty. If here is one vector mapped of an ejection coming from the nucleus, and it's constant, you'll see it as a frequency. Over here, the frequency of the observer sees that light hit so many times a second, so it's frequency. So the energy is based off the frequency, not off the wavelength. The wavelength is the distance between these two peaks. If you move closer, the wavelength goes higher. If you move further away, the wavelength goes down. That's just the wavelength in this theory doesn't really exist, but it's instead the space between the two seen, uh, I guess, flashes of energy. I guess the two quanta of energy. Uh, but anyway, um, where I'm at on the equation, the frequency is equal to the rotational frequency of the particle times the speed of light plus the velocity of the particle. So it says if the particle is moving, in which direction that it affects the frequency you see, and plus the velocity of the observer. So when you add the observer in there, that changes the frequency too. But that equation is actually not right. Okay, been working on it. But you also have to deal with the decay of energy over space. You know how far it goes away, and the charge in the nucleus. So this is where I'm at right now, where the energy over time, the average energy, is equal to the charge pi over the rotational frequency of the nucleus times the speed of light plus the velocity of the particle. All that is together times r squared to show the decay plus the velocity of the observer. Alrighty. I know it's really not much to go on right now, but I'll be writing a paper on it and figuring out the rest of this, but hopefully it'll add up quite nicely. Yeah, there's a lot of information right here. Anyway, yeah, I'll try and keep you posted. Thanks.